Welcome to my YouTube channel. In this video lecture, I am going to answer all the questions from sample paper number 3 RK Bali Navigation book. This is the 4th edition book. Even if you tend to have any other edition book like the 5th, the 6th or the 7th, it won't be a problem because all the questions remain the same whether you take the 4th edition book, the 5th edition or the 6th edition. So let's begin with the very first question. Simple theoretical question. The angle between the plane of the ecliptic and plane of the equator is what? Now we all know that the earth revolves around the sun. The earth revolves around the sun in an elliptical orbit. In an elliptical orbit, somewhat like this. Okay. It revolves around the sun in an elliptical orbit. And the equator, let's say this is your equator. So the angle between the equator and this elliptical orbit will be what? So this is your elliptical orbit, and this is your equator, right? So the angle between them is this angle. This angle between them is 23.5 degrees. 23.5 degrees. So this 23.5 degree angle is called, it is called plane of equinoctial. Plane of equinoctial. Remember this for your STL YY exam. So this angle is your 23.5 degree angle. So the angle between the elliptical orbit of the earth around the sun and your equator is 23.5 degrees. A rhumb line is a line on the surface of the earth cutting all meridians at the same angle. Any straight line on a Lambert's chart, a line convex to the nearest pole on a Mercator projection. So we all know that the definition of a rhumb line says it is a line on the surface of the earth cutting all meridians at one same angle, or any line on the surface of the earth which has a constant direction. So accordingly, option A will be the correct option. Bravo is wrong because any straight line on Lambert's chart is a meridian. It's a meridian. A line convex to the nearest pole on Mercator projection is a great circle, not a rhumb line. So correct option is option alpha. If you want to follow a constant through track, okay, you must fly a great circle, you must fly a rhumb line, you in most cases will also fly the shortest possible track. So if you want to fly a constant through track, by definition, you will fly a rhumb line track. On the other hand, a great circle track is a track of constantly changing direction. But the advantage is that when you follow a great circle track, you will be flying the shortest route, the shortest distance between any two points. So option alpha and Charlie are wrong. Bravo is the correct one. Similarly, there is one question number 10. In order to fly from position A, which is 10 north 30 west, to position Bravo, which is 30 north 50 west, maintaining a constant, you have to maintain a constant true course. That means you have to maintain a constant direction. It is necessary to fly what? A great circle, a straight line, a rhumb line track. So again, you will fly a rhumb line track because by definition, a rhumb line track is a track of a constant true direction, whatever direction, but a constant direction. Okay. So let's come back to question 4. So I took that question in between because it was similar to this concept. The concept is the same. Now, which of the following differences in latitude will produce the greatest difference between the initial great circle track and mean great circle track between 2 points which are separated by 15-degree change in longitude? Now here mean great circle track is your rhumb line track. Let's say these are the 2 points here. This is your rhumb line track. The points are in the northern hemisphere. This is the great circle track. Okay. Now the great circle track at this particular point will be parallel to this rhumb line. Okay. At this particular point, it will be parallel. The track direction will be parallel to the rhumb line direction. and we know that that point is right in the center of this great circle track. So we call it average great circle track. Average great circle track. So instead of saying run line track, okay, we call it average great circle track because at that point it will be parallel to the run line. The direction of that great circle track at that particular place will be just like will be the same as your run line track. So instead of saying run line track, we can also say average great circle track. Okay. Next. Now the difference between great circle and mean great circle track, that is difference between a great circle and a run line, is your convergency angle. The angle between great circle track and a run line track. Okay. Convergency angle is nothing but half of convergency. What is convergency? Convergency is d long in degrees into sine of latitude. That means convergence is proportional to latitude. More bigger the latitude, bigger will be the convergency value, and indirectly again in turn, bigger will be the value of convergency angle. So let's check all these three options. Option A is 30 south and 25 south. 30 south and 25 south. So D long is 15 degrees. Sine of latitude. Latitude we are going to consider the average of 30 and 25, which is 27.5. Sine of 27.5. So sine 27.5 is 0.46 multiplied by 15 is 6.9 or 7 degree, approximately 7 degree. So convergency angle will be 3.5 degrees. The convergency in this next case, option Bravo, 30 south and 30 north. Now here, this latitudes are in the different hemisphere. One is in the south and another is in the north. So we cannot consider that. We will only consider those latitudes which fall in the same hemisphere. So we'll come to C, option Charlie, 60 north and 55-degree north. So again 15 degree into sine of latitude. So the average of 55 and 60 north is 57.5. Sine of 57.5. So what is sine of 57.5? 0.843 something multiplied by 15 is 12.6. So approximately 13 degree. So convergency angle will be half of 13 degree, which is 6.5 degree. Now, what angle is more than the other? So convergency angle of 6.5 degree is more than convergency angle 3.5 degree. So therefore, option C will be the right answer. These two latitudes, 60 north and 55 north, will produce the greatest difference between great circle track and run line track. Okay. Position A and B are given to you. What is the run line bearing from A to B? If great circle A to B is 100 at A. So A is 58 north 30 west, B is 51 north 20 west. So this is your great circle, this is your run line. Now, run line track, correction, great circle track A to B is 100. Coordinates 58 north, 30 west, 51 north, 20 west. Okay, so great circle A to B is 100. Run line A to B will be this bigger angle. Okay, this bigger angle. Now run line A to B is great circle A to B plus this angle plus this small angle, which is your convergency angle. Convergency angle. So run line at A is made of two parts. It is made of great circle and convergency angle. We do know great circle is 100. Now what will be the convergency angle? So To find that out, we will have to find out convergency first, which is d long in degrees into sine of latitude. So d long, difference between 30 west and 20 west is 10 degree. Sine of latitude 58 north and 51 north. So average of that will be 54.5. So sine of 54.5. Sine 54.5 multiplied by 10 is 8 degree. So convergency angle will be 4 degree. So 100 plus 4, 104 degree. So rhumb line at A is 104 degree. Option Charlie. Question 6. The country is having a standard time slow on UTC. Pay attention to the word slow. So let's consider this is your Earth. Okay, on this Earth we have a prime meridian in the center, and the time kept with respect to this prime meridian will be UTC time. All the eastern longitudes will run ahead in time. Okay, they will run ahead in time compared to their western longitude. So any place in the eastern hemisphere will always run ahead in time compared to its western longitude. So let's say UTC meridian or any other place in the western hemisphere. On the other hand, any place in the western hemisphere will run behind in time compared to their eastern longitudes. Let's say any place in the western hemisphere will be running behind in time compared to the UTC time on the prime meridian. So now here it's said in the question, standard time is slow on UTC. Place which will be slow on UTC will be running behind UTC time. So that is only possible when the place is in the western hemisphere, any western longitude, because UTC meridian is to the east of western longitude. Will be option Charlie. Will generally be located at western longitudes. Isogonic lines connect positions that have same variation. Lines that connect 0 degree variation are agonic lines. Compass deviation is what? It's the angle between magnetic track and compass track. So deviation is the angle, is the connecting link between magnetic direction and compass direction. So correct option is option Bravo. Question 9. What is the final position? What is the final destination after your aircraft starts flying from 60 degree north, 30 degree west? Then it from that position it flies south for 360 miles. Then it flies east for another 360 miles. Then it flies north and then again it flies west. So after the end of the flight, what will be its final location, position? So let's plot this 60 north, 30 west. Okay. Total distance is 360 nautical miles. So it is flying, aircraft is flying south 360 nautical miles. Now when you fly along a fixed longitude between two different latitudes, you fly a great circle track. So apply great circle distance formula, which is d lat into 60. So 360 into equals to d lat into 60. D lat in degrees will be 360 divided by 60. So d lat in degrees will be 6 degrees. So your new latitude will be 60 north minus 6 degree. Why? You are in the northern hemisphere and you are flying in the south direction. So the values of all latitudes decrease when you are in the northern hemisphere and you fly southerly direction up to equator. So new latitude will be 60 north minus 6, 54 north. Longitude is going to remain same, 30 west. Now from here you fly easterly direction for another 360 miles for another 360 nautical miles. So now you will be flying a rumline track, rumline distance, because when you fly along a fixed latitude, 54 knot between two different longitudes, you fly a rumline track. So rumline distance is d long in minutes into cos lat. So 360 equals to d long in minutes into cos 54. So d long in minutes equals to 360 divided by cos 54. That is 612 minutes. Now 612 minutes equals to 10 degree 12 minutes. 10 degree 12 minutes. So your new position will be same latitude 54 north, but the longitude will be different. Now you are in the western hemisphere 30 west, you are flying eastwards. So the value of longitude will decrease. So 30 west minus d long 10 degree 12 minutes. 30 degree minus 10 degree 12 minutes is 19 degree 48 minutes west. Now from here you fly north again for the same distance 360 nautical miles. Okay, just like this. So that means your new location will be, so again over here d lat will be same, d lat will be the same as this 6 degree, because you are flying parallel to this, like that. So your new latitude will be 54 north plus 6 degrees, that is 60 north. So 60 north, 19 degree 48 minutes west. Now from here, from this position you fly a westerly track for 360 nautical miles. For 360 nautical miles. Now when you fly a westerly track of 360 nautical miles, your end destination, your final position will be beyond this point somewhere here. Why is that? Because remember the concept of convergency. Okay, this is your earth, let's say. All meridians converge on the surface of the earth. So let's take these two meridians. So the two meridians that we have is uh, 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 any meridian, 30 west and 19 degree 48 minutes west, approximately 20 west, and latitude is 54 north and 60 north. Okay, so this is 30 west longitude and this is 20 west, let's say. Now you can see the spacing between the meridians decrease as you fly from equator to higher and higher latitudes. Okay, the spacing decreases, spacing goes on decreasing. So now we have two latitudes here, 54 north and 60 north. So see, the difference between two longitudes 30 west and 20 west, the distance between them is more at 54 north compared to 60 north, right? So d long is the same. D long at 54 north is 10 degree 30 west minus 20 west. D long at 60 north will also remain the same, 30 west minus 20 west. What will change is the distance. If at 54 knot the distance is 360 nautical miles, this much. So at 60 knot, the same 360 nautical miles will be this distance and a little bit outside, because we will have to compensate the small spacing between the two meridians by covering an extra distance outside that meridian. Okay, so 360 here will be equal to 360 that much. So that's why our final destination will be beyond this meridian, beyond this 30-degree west meridian, somewhere here, somewhere there. So I'll show you the proof. Now Ramline distance is d long in minutes into cos lat, right? So 360 d long in minutes into cos of 60. So d log in minutes will be 360 divided by cos 60, that is 720 minutes. 720 minutes is nothing but 12 degree. So your new longitude, this new longitude will be, latitude will remain the same. Latitude will remain the same 60 north, but longitude will be 19 degree 48 minutes west plus 12 degree. So new longitude will be 12 plus 19 degree 48 minutes, that is 31 degree 48 minutes. 31 degree 48 minutes west. So this is your 30 degree west longitude. And your new longitude, this new longitude is 31 degree 48 minutes west. So 1 degree 48 minutes more than 30 degree west. Okay. So what is the final destination? It is 60 north, 31 degree 48 minutes west. Question number 10, I have solved it just a few minutes before. So it is a rumline track. You want to fly from A to B, maintaining a constant true track. So you will fly a rumline track. So this concludes our lecture. I hope you have understood all the 10 questions I answered and explained in this video lecture. Keep practicing these questions again and again. Also practice questions from other sample solved papers that I have uploaded to my YouTube channel. Look at the video lectures in which I have solved multiple questions from RK Bali, Oxford, Keith Williams. So explore this channel. You will find all the videos in different dedicated playlists. I have made separate playlists for every textbook. So you will find the videos there. I request you all to share this video and this channel with your friends who might also benefit from this work. Subscribe if you haven't yet and hit the like button if you have liked this video lecture. Thank you for your time.